disconnected and we're trying to reconnect. And for those who are using or working with remote protocols for a long time, like I am, you probably remember that at some point Citrix added a feature called session reliability that is acting like a proxy between the actual application, which was terminal server, and the networking protocol, just to make sure that when the TCP connection is dropped, it's not necessarily mean that we should disconnect the user session. So there was workarounds like that for TCP, but at the end, what we see right now that most of the protocols are using UDP, and like when I talk to customers, when I'm saying like, okay, guys, TCP is unreliable and UDP is reliable, they don't get it. They think it's kind of joke, especially those who actually like know the OSI model and they learned about the UDP and TCP protocols, how they different, and they think like, no, TCP is reliable. So let me talk about the primary functions of the transport protocol. So first of all, the transport protocol for interactive connections should be reliable. It should deliver. It should deliver the packets when they have to be delivered, because it's interactive traffic. When you click on something, you wanted to receive the feedback. When you type your email in Outlook that is published, and you expect that all the letters that you type it will actually be sent to the server, and they will be actually presented back to you in form of the graphics. So it should be reliable, and it should be reliable in form that if there is some network glitch, or the router, your home router is having trouble, or there is congestion on the network, the packets should be reliably delivered, and your high level, your protocol will not really be broken by the fact that some of the packets were either corrupted or blocked. And there are a few methods of doing this. There is a retransmission. That's how TCP do this. There is another method of doing this is forward error correction, and where the data is duplicated across the packets, and you can you send basically you send 3 packets where when you like it's on the minimum level, it would be like 2 packets, and you can, if you lose 1 packet, you can reassemble the entire message. Forward correction is great, but it adds the overhead, and depending on the percentage that you set. There is another method that we are using in RDP called selective acknowledgement. Basically, we send the request to retry only if we are missing some packet. Another functions of the remote protocol is congestion control, making sure that every time when you send the packets, they will be delivered in time and they will not stuck in the queue. And when you use the basic functionality like TCP, you don't have any control over this congestion control, because it's on the protocol level. When you take the UDP as a transport and use it, you can implement your own congestion control. And this congestion control can include the high-level work. Basically, you can see that your network is congested, and you can reduce the quality of your images, or you can decide that you deprioritize, let's say, file transfers, and like send them at the lower rate, or you can deprioritize some other virtual channels, or you can, as example, just reduce the frame rate and send less frames, or like send them with a lower resolution if it's acceptable. So there is a lot of things that you can do with deep insight in the protocol. And when we were working on the UDP implementation for AVD, we had different ideas in mind. Like we obviously looked what our partners are doing, or partners, or let's say competitors, depends on how you call it. But in general, there are different approaches. Most of the partners, most of the vendors on the market, they are reusing some of the open source protocols for their needs. As example, there's a general purpose protocol called Quick, which is kind of replacement for the future for the HTTP, and it can use TCP, it can use UDP, and this protocol is heavily used by some of the protocols or some of the remoting protocols because it's easy to implement. The Quick protocol itself have more more things that you can adjust, but it's not so flexible as custom implementation. Another common protocol is UDT, which is for some of you probably known as EDT. It's very reliable, high performance transport that some of the partners are using based on UDP. But again, it's open source implementation that that can be used by the partners. There are standard protocols like RTP or TCP that are used in WebRTC, same WebRTC that is used by Teams that we're using right now. And one last implementation that I would say less ideal is just using the IPsec VPN that is UDP based to deliver the data. In that case, you have much less control from the protocol itself on the congestion control, on any other aspects, because all the packets are encrypted and there's no direct visibility into the network. So it's like with any VPN, you have no idea what is going on over the network. So instead of reusing the standard public protocols, what we are using in RDP is URCP. URCP is Universal Unified Rate Control Protocol. It's a product of Microsoft Research, and it's not new to AVD. URCP as a transport was initially introduced with original implementation of UDP in Windows 8. Oh, sorry, 8.1. And there was some fixes that we had, some stability fixes. So we were not using it by default. We were using it at that time by in some specific scenarios. But in Windows Server 2019, URCP as the transport was enabled as the default transport for UDP communication in RDP. So every time when you connect in with Windows 10 client to Windows Server 2019 or higher, or Windows Server 2022, you are always using URCP as the backend transport for the UDP channel. And just to clarify, like when we talk about on-prem environments, the connection, there are two connections going simultaneously. One is TCP connection, another is UDP connection. And they are going to the same IP address, but the UDP portion of it is using URCP and get all those benefits that I will be talking about. So we are reusing the same URCP. We added more on top. I will talk about that. But in a nutshell, it's not something completely new or something that you would expect be unstable or something like that. It's a technology that we're using for all the deployments for a while, since what it was, like 2015 or something like that. So URCP is a set of algorithms on how to monitor the network and how to provide the feedback back to the higher level, to the protocol itself, to the encoders, to the graphics pipeline, and URCP do this by measuring the delivery time for each packet that we send to the network. We can learn immediately about the available bandwidth based on the delays that happens with the packet, because obviously if you send more data than network can handle, it will be delayed by some of the routers. And based on this, there's pretty straightforward formula that can give you the bandwidth estimation. So every time when we talk about RDP estimating the bandwidth, available bandwidth, it's not like we do. It is not the same way like I don't know, speed test is doing this, because speed test is just sending a lot of data until your pipe is filled, and then measuring how much data it was able to send. With RDP, it's completely different. We are sending the data that you actually use, like your keystrokes, your screen updates, and we measure how much time it takes to deliver to another end, and we know based on that what is your bandwidth and what is your delays, and we like dynamically adjust. As example, if you are moving through the building and you connect it with Wi-Fi and you're moving from one access point to another, and or you like driving and you have a 5G or 4G connection, we will dynamically see if your network conditions are changing, and we will report it back to the RDP, and RDP graphics pipeline will adjust, and other components of RDP would be adjusted. It is much better than TCP. It gives less delay because we're fully in control of what we send in, and it provides better like bandwidth utilization in general. We use URCP, but when we use URCP for on-prem deployments, and we use URCP even for deployments with the gateway. Like if we take a regular RDSH environment, you can use UDP connections with the RD gateway, but from the first day when AVD was released to the market, when it was WVD, like every smart guy in the room noticed that there is no UDP support for RDP, and it's TCP only. And like many people were asking on Twitter or in different forums, like, oh, why don't you just add the RD gateway? Why you don't just create the gateway for the UDP traffic? And there are several reasons why we didn't do this in the first place. So first of all, those who are familiar with AVD, they know that we use reverse connect feature. It is similar to something that other vendors call rendezvous connection. Basically, your client and your server connecting to the gateway, they making the outbound connection, and the gateway actually transfer packets from one connection to another. So at the end, your gateway is actually decrypting the SSL tunnel, the WebSocket tunnel on both ends, and transfer the packets, the RDP packets between two WebSocket channels. Don't worry, it's still secure, because within that WebSocket channel, you still have another SSL tunnel that is RDP specific, and that is encrypted with your certificate that you install on your session host. However, the work to decrypt SSL and re-encrypt, while it might be not significant when you browse the websites. At the scale of AVD, it's a pretty significant amount of the CPU CPU utilization for all of the tenants, all of the users that we serve in the world, and it could be a bottleneck. And with move to UDP, it will mean that like UDP as more efficient protocol will give more data, and it will be just a rabbit hole. You put more data, and you have the gateway that is not capable of decrypting this. Another problem with the UDP gateway is session tracking. Obviously, it is possible, but it is difficult to track the UDP streams. UDP is a connectionless protocol. It doesn't have attributes of the session in the packet, and AVD being truly multi-tenant service, session tracking is something that is not super critical, super difficult to implement, but it is challenging, and it's less problematic in the single tenant environment, some of our partners do when they deploy the gateway specific to the tenant. It's less critical, but in the shared environment like we have, it is additional security challenge. However, it's not the most important reasons why we didn't choose this path. I will talk about the actual reasons later. Just for the reference, the implementation of UDP transports across different protocols is very different. And when we talk about the cloud services or services that are used over the internet with the gateways, most of the vendors have some kind of gateway, and it is either the similar to reverse connect, like Rendezvous, or in most cases, it is connection from the client to the gateway, and the gateway then connects to the backend server. So it is basically inbound connection for your session host. So we don't want to do this this way, and like as I said before, we have reverse connect, and reverse connect works great. So from the security perspective, our customers love it because you don't need to configure any firewall rules for inbound connection. You just configure regular access to the internet, and over port 443 with SSL, you are getting connected from your VM running in your private network. You may even configure your Azure firewall to allow access only to AVD services and prevent the internet access completely from the VM. So this is possible, and you don't have to have any public IPs assigned to the VMs, or you don't have to have any inbound DNet rules on your firewall. So customers love it, and we want to keep this. We don't want to add any UDP specific listeners or custom gateways. That was one of the reasons. But besides the challenges with performance and security of the gateway, we want to make sure that every time we add a new feature that is related to the interactive RDP protocol, the transport that supporting this interactivity, we want to make sure that we are not introducing anything that can be broken. So ideally, we don't want to have gateway at all. And we would like to have a direct connection because it will reduce the places where you can get the bottleneck. It will say make service cheaper, which is in the end would be better for the customers, and it will be just faster because there will be less latency. Like the WebSocket relay adds at least 5 to 10 milliseconds latency depending on the load, and this is it doesn't sound too much latency, but it's just the gateway itself, the processing within the gateway, decoding and re-encoding the packets. However, the placement of the gateway will affect your network latency. So getting rid of the gateway makes your connection just faster, and it will use all available bandwidth without throttling that might happen on the relay in the shared configuration. Without the gateway, you will have faster reconnect time, and basically the less points of failure you have on the path of the RDP packet, easier then it is easier to troubleshoot the connectivity. So what we do with AVD? First of all, we are released the like, let's say, simpler implementation of RDP to GA back last year. We released RDP Shortpath for the managed networks. And RDP Shortpath for the managed networks, it's heavily used by many customers. I hope someone on the call also have it in their environments that we can discuss some details of that. But this feature was initially designed for the customers that have users sitting on-prem and connecting to their VMs over ExpressRoute. Basically, the ask was like, I already have the ExpressRoute connectivity to Azure. I don't want my data flowing over the internet for no reason. And we like in those cases, and in cases where our customers are using Azure Stack HCI as example, they don't want the RDP traffic to go to another location. So we have this feature for a while. It was in the public preview for about like 10 months, and it's GA since I believe October last year. Pretty heavy usage, but obviously with COVID, it's not exactly the usage that we expected when we started, and we started before the COVID happened. So like many people are sitting at home, they don't go to the office, so they don't have ExpressRoute. And while we support VPN connections, I would discourage you from using VPN connections for Shortpath for managed networks because it may affect the performance. So we, like in the background, we were working on something else, and in a few weeks, up to a couple of months, I hope we will announce the public preview of, I mean, it's already announced, but we will start the public preview of RDP Shortpath for the public networks. RDP Shortpath for the public networks is a new way of connecting the transport, the same URCP transport that you have with Shortpath for managed networks or with on-prem connections. It's just a new way of finding this path. I think I need to skip this slide. So what's going on with RDP Shortpath for public networks? We are trying to discover the path, direct path that is technically possible in most cases between client and the session host without asking the IT admin to open any firewalls for inbound connection. And to perform this, we are we're doing this in parallel. Basically, if when user is connected, we are using the same reverse connect, same path that is proven as being successful for establishing connections, and we use it. We use it in both Shortpath for managed networks and for Shortpath for the public networks. We establish a WebSocket connection, and then we, like in parallel, we're trying to discover the UDP path. And if it's possible, then we switch everything to the UDP transport. And the difference here between Shortpath for managed networks and Shortpath for public networks is that with Shortpath for managed networks, if anyone tried to implement it and read the documentation, you actually configuring the UDP listener on each individual VM on port 3390, and then you configure your express route firewall to pass this traffic from the client to the server. In case of Shortpath public, we are using a set of the protocols that is called ICE and STAN. ICE is, let's start with STAN. STAN is simple traversal utilities for NAT. Basically, it's a set of the algorithms that is using standard ways of communication over the network to discover the availability of the UDP socket. Basically, it is. Let me see what kind of slide I have with details here. Yeah. So basically, we are finding the external IP address of both client and the session host, and we're using it for the connectivity. And ICE is basically a set of algorithms on how to exchange the information about the client and the host. And I will actually have a little bit of demo at the end, and we'll be open to questions. But just want to show, like, if you're not aware how STAN works. First of all, you can Google it. It's not a proprietary technology that we invented. It's a standard set of protocols. STAN is described in the RFC. ICE is described in RFC. And what it does, it basically gives you an option to discover the public IP address. So if you are on the home network, as example, and you want to know the public IP address of your router, what you usually do, you go, like, you open Google or Bing, and or like you know the website, something like, what is my public IP, or what is my IP.com, and when you open it, it shows you the public IP of your home router. So what happens in this case in the background with regular TCP connection with your browser, your client, which is on the home network, like 10.0.1.1 something, open the TCP socket and send the request to the public IP address of the web server. And the public IP address of the web server is in a public network. You are on a local network. So you obviously have a network address translation on your router. So your router is taking the packet and change the change the source IP and source port to the public interface of this router, and then this packet would be routed to the web server on internet, and web server will receive it and will see where this packet is coming from, and it will see the public IP address of your router, and it will just report it on your on your web page. So with STAN, we do exactly the same thing. The client that is sitting on your private network opens the UDP socket and send the packet to the well-known server. And we are using STAN infrastructure that is supporting this call right now with Teams. We're basically reusing the Teams infrastructure for the communication. We send in the packet to the STAN server, and STAN server respond back with another packet. So it's pretty quick. It's two small UDP packets that are exchanged, and we now know the external IP and port that was used for the translation. The same happens on the session host. Session host sends the packet to the similar server and get this information. Then we collect information about all local interfaces. Like on your session host, most likely you will have just one interface. On your client, you might have the Wi-Fi network, you might have the wired network connected, you might have some VPNs, you might have IPv6 and IPv4 simultaneously on some of the interfaces. So we collect all of this information and we exchange this information between client and the session host. And then both client and the session host are trying to find the pair and trying to connect. And when we find the pair and we see the packets flowing back and forth, we just nominate it as the transport, and we use this new transport to switch over all of the graphics, all of the keyboard, mouse, and the rest of the RDP traffic to this new transport. And eventually, we will even disconnect the TCP transport that was initially used for session establishment. So this works with different weird types of connections. As example, if you have T-reader, which is something that you might have, especially in your home environment, or you specifically configured your session hosts to participate in optimized delivery or any or some other Windows components that are using T-reader. You will get the IPv6 address, and if you have IPv6 on your client, you will get the connection over the IPv6, even if you like the RD gateways and RD infrastructure doesn't use IPv6 at all. And there's a lot of funny ways how it gets connected. So what we do, we try to find the fastest way for the connectivity and use it for the connection. So I have a pretty quick demo. I don't want to do like I usually prefer to not make a live demos.
Dennis, did you want to answer any questions that's in the chat right now before you do the demo, or after?
Let me just show this demo first, and then I will go through the chat, or like we will go through the chat, and I will answer this question. The demo is pretty simple. Let me share my screen. Just a second. Share screen number 2. Okay. So what you see, and I hope I don't have screen capture protection enabled. I haven't checked. Do you see the desktop?
Yes.
Yes.
Yeah, perfect. So it's a standard session, and if you click here, it shows that UDP is enabled. And when you click to see details, it shows that it's UDP, round trip time of 14 milliseconds, 29 megabits available bandwidth, and you see the gateway is not in use. So nice thing. I would say there is no gateway and it's direct UDP connection. To prove that, I have a process monitor. So when I launched this session, I captured the process monitor, and you can see there's some UDP send receive packets. That's what I was talking about the discovery of the UDP package of your external IP address. Then you have some TCP connections, and I will actually like scroll a little bit. There's a lot of TCP connections for session establishment, for the telemetry, things like that. And let me scroll. Yeah, you can see that there is some attempts of UDP connectivity over the IPv6 addresses, which are actually local addresses, so they were not succeeded. There's just send, but no response. There's no route. That's okay. We try in different interfaces. So we try and then like if I will scroll to the end, you will see that I have just UDP send, UDP receive, and it's the public IP address of the Azure firewall that is in front of my connections. You see TCP was disconnected, and I have like, if I will run something like netstat, you will see that MSRDC, my AVD client, have no TCP connections at all. You might see some of them, but it would be the diagnostics. There are no connections for RDP. So that's conclude my live demo, and I'm ready for the questions and ready to be ready to answer them. Then can you read the questions to make it?
Sure. Yeah. So Justin had a question earlier about for RDP Shortpath, is there any plans on the horizon to not require the endpoints being exposed to the public internet?
You kind of answered it a little bit later on in your presentation, right, with express routes. And yeah, so thank you. Any timelines wrapped around that?
So we targeting the public preview pretty soon, like within the few weeks. There's some deployments that we need to make to enable it for everyone. But it's a short term. We will be in public preview. Obviously, GA would be quality based. When we will be ready, when we will see that the connections are stable and performing well, we will move to GA. But it's pretty soon. We targeting Q1 this year for all of this.
Thanks, Denis.
Yeah, and it doesn't. So as I said, there is no requirement to configure any public ports or public endpoints, and I mean, there is absolutely no requirement. However, the feature itself, the discovery, is best effort. Basically, we are trying to discover, and we're trying to find this path. And depending on some of the sub features within the feature, we have a success rate. At minimum, what we see in the prototype, at minimum we seen about 45% success rate for the direct UDP connection. And there are some additional features that we will turn on right after the public preview, or document them during the public review, that can increase the success rate to 95% of the connection, and for the direct. But I want to clarify here that it basically means that feature performed after discovery in the conditions that are unknown and uncontrolled by the RDP code. However, there will be recommendations on how to configure the network to increase the chance of the successful connection. And like overall across the service, we don't expect 100% of connections to go UDP. We have a lot of customers that just block UDP and they don't care about performance. They don't care about anything else. They think that TCP is easier to track for the security purposes, and they do the packet inspection, and they don't want UDP on their network. So those customers, unfortunately, out of luck unless they change the firewall rules. And this may affect some of the end user scenarios. Let's say you have environment that is accessed by contractors, and those contractors, in fact, may have a strict policies, and they use something like Zscaler for all outbound connections, and they don't allow UDP. So those users will just continue to use TCP, and that's totally fine. It's the protocol. It's a transport that is used by majority of the AVD customers today. However, there is absolutely no need, and it's not recommended to add any public endpoints. However, if you will add the public endpoint to your VM, it is, I would say, like 99.99% of the guarantee that you will get the UDP connection.